So our today's topic is LCM and GCD, that is least common multiple and greatest common divisor. Okay, so you know few basics about this least common multiple. Okay, first we need to find the multiples, then we need to find the common multiples in that, and then we need to find the least common multiple in that. Okay, so GCD and LCM is for two numbers. Okay, for two numbers we'll have GCD, for two numbers we'll have LCD. So for two or more numbers also we'll have LCD and GCD. At least two numbers are required to find out LCM or GCD. Okay, so let's go with the basic definitions of LCM. So these are all the basic definitions we have LCM. So these basics are, you need to read it. I'll send you this document to you. Just read it. So I'll just go with the flow. So least common multiple. The least number which is exactly divisible by each one of the given number is called as LCM. Okay. So LCM of 16 and 12. Okay. So how do we find out LCM of 16 and 12? So first we need to find out what are the common multiples of 16 and what are the common multiples of 20. So first we will go with multiples. What are the multiples we have for 16? Okay, so multiples for 16, which means what? In the 16 multiplication table, the numbers which are there on the right side, that we called as the multiples. Okay, so 16 multiples are what? 16, next 32, next 48, and then 64, and then 80, and then 96, and so on. Okay, so multiples are unlimited. Remember this point, multiples are unlimited. Now what about the 20 multiples? So 20 multiples are nothing but what? 20 into 1 equal to 20. So these are called as multiples, these are called as factors. Now 20 multiples are what? 20, 40, 60, 80, 100, and so on. So these are all 20 multiples. So we find out multiples first. Okay, we find out multiples first. Multiples of 16 and 20 are what? Something like this. Next, common multiples of 16 and 20. What are the common multiples of 16 and 20? See, if you observe here, if you observe in this case, we have a common multiple, that is 80 and 80. So if you go forward, we'll have few more. If you go forward, we have few more common multiples. But as of now, in this example, we find only 80 is a common multiple. Now in that case, we'll go with least common multiple. Okay, what is the least common multiple? So in this, the common multiples are started from 80. So that is the least common multiple. So this is how we need to find out. This is one way of finding least common multiple. First we need to find out multiples, then we need to find out common multiples, and then we need to find out least common multiple in that. Okay, so what is the LCM of 16 and 20? That is 80. Okay, 80 is the least common multiple. Now if you write 80 here and read it, 80 is the smallest number, that is both multiple of 16 and 20. So that is the exact definition for least common multiple. So this is looks like a lengthy one. Sometimes this will be very easy if you have a very small numbers. If you have a bigger numbers, it will be definitely hard to find out. Okay, so for small numbers we can easily find out. For bigger numbers కొంచెం కాంప్లెక్స్ అవుతుంది. So for that we have few methods. Okay, so the first method, okay, the first method is factorization method. What's a factorization method? Resolve each one of the given numbers into a product of prime factors. Okay, so how do we write it as a prime factors? That is prime factorization form. So 16 prime factorization form. 16 we can write it as 8 into 2. 8 we can write it as 2 cube into 2. So directly we can write it as 2 power 4. Okay, so 16 we can write it as 2 power 4. That is the prime number power. This is a prime factorization form. Now 20. What's a prime factorization form of 20? 20 we can write it as 4 into 5, and 4 we can write it as 2 square into 5. Okay, so this is the prime factorization form. Okay, so prime factorization form of 16 is 2 power 4. Prime factorization form of 20 is 2 square into 5. Okay, now after this what we have to do? See, the LCM is a product of highest powers of all the factors. Now what are the factors we have? 2 is a factor and 5 is a factor. Okay, 2 and 5 are the factors which are common in these two, the highest powers of all the factors. So what is the highest power of 2 here? 2 square in the below, 2 power 4 in the above. So highest factor is 2 power 4. 2 power 4, and when it comes to 5, only one 5 we have, that is 5 power 1. Okay, 5 power 1 is the highest factors of 5. Now just we need to multiply this. So if you multiply this, 2 power 4 is 16 and 5, which is 80. Okay, this is one way of doing. So 80 is the common LCM of 16 and 20. So what is the way here? Factorization method means what? First we need to convert that 16 into prime factorization form. Then we need to check the highest powers of the prime factors. So here the highest powers of prime factor is 2 power 4 and 5 power 1. So 2 power 4 and 5 power 1, the multiplication is 80. So this is one way of doing. Okay, maybe you know about this or you may not be, but you know one method. So that is this method, division method. Division method, you know this because in our childhood we learned this. Arrange the given numbers in a 2 in any order, divide by a number which is divided by exactly at least of the given numbers. Okay, these terms may be complicated, but when you see the method you can easily understand. 16 and 20. So this is a method. So 4 fours are and 4 fives are. Okay, so 4 you can write it like 5. Okay, so just 5 fours are 20, 24 are 80. Okay, so 5 fours are 20, 24 are 80. So this method you know very well. Okay, this is the LCM method generally we follow. Okay, so other than that we also have one more method, that is this, which is a factorization method, and we also have one more method. This is the elaborative method of least common multiple. So as of now we learned three methods. Now the next, that is about LCM, and the next about greatest common divisor. Okay, so divisor means what? A factor, the highest common factor. This we also call it as HCF. Few authors call it as HCF. Few authors call it as greatest common measure, and few authors call it as GCD. So anything is same. HCF or GCD or GCM. Anything is same. Now the HCF of 2 or more than 2 numbers is the greatest number that divides each of them exactly. Okay. So this is HCF. Okay. Now we'll go with the elaborative method as we learned initially. So we need to remind about the factor. First we need to find out the factors of 16. Okay. So factors of 16 means what? Uh, in which multiplication we'll have 16. In which multiplication we have 16 multiplication table. In one multiplication we have 16. So 1. In two multiplication table also we have 16. 2. In 3 multiplication table we don't have 16. In 4 multiplication table we have 16. 5 we don't have, 6 we don't have, 8 we have, and the next 16. Okay, so these are all the factors of 16. So these are all factors of 16. Next, factors of 20. What are the factors of 20? 1 is a factor of 20, 2 is a factor of 20, 4 is a factor of 20, 5 is a factor of 20, 10 is a factor of 20, and 20 is a factor of 20. So these are all the factors of 20. Okay, factors of 20. So first what we have find out, factors we find out. Next, common factors. What are the common factors here we have? Okay, so the common factors are what? That is 1 is a common factor, 2 is a common factor, 4 is a common factor, and yes, these are all the common factors. Next, highest common factor. What is the highest common factor? See here, this 4 is the highest common factor of 16 and 20. Okay, so the highest common factor of 16 and 20 is 4. Okay, this is one elaborative method to find out the greatest common factor or the greatest common divisor or the highest common factor. Now again we'll have two more methods here. Again the same factorization method we have. So what's a factorization method? Again we'll do the same. So 16 we can write it as 2 power 4. Okay, 2 power 4, and 20 we can write it as 2 square and 5. Okay, 2 square and 5. What is the greatest common divisor here? See, the product of least power, the product of least power of a common prime factor. So what is a common prime factor here? 2 is a common prime factor. 2 is a common prime factor here. And for 2, what's the least power? least power of 2. So here we have 2 power 4 and here we have 2 square. So what is the least common power here? That is 2 square, which means 4. So 4 is a HCF of 16 and 20. Okay. So this is one more method that find out the GCD. Next, other than that, you all know this method. Okay, in a childhood we learned this method, which is the division method. Okay, how do we find out? So 16 we can write it like this: 20, 16 ones are 16. Okay, we left with 4 as a remainder. Again we consider this one. Okay, so this 16 comes here. 4 4 is 16, which is 0. Okay, so greatest common divisor. So what is the greatest common divisor here? This is the greatest common divisor. So this is HCF. So this is one more method. So to learn HCF we have three methods. I mean, to find out HCF we have three methods. To find out LCM we have three methods. So whichever is comfortable, you just go with that method. Okay. And we also have to find out sometimes more than three numbers HCF, more than three numbers LCM. More than three numbers LCM is very easy. Okay. How do we write down? So if we have three numbers, we can simply write the one number here. We can easily find out. But when it comes to HCF, it's little not actually complicated. So it's we need to find out. See, suppose we want to find out HCF of three numbers. Okay, if you want to find out HCF of three numbers, then find out HCF of any two numbers. So first we need to find out the HCF of any two numbers. Then later we need to combine with the third one. Okay, so that gives you the HCF of three numbers. Okay, so for example, if X, Y, Z, if you need to find out HCF of X, Y, Z, how do we do it? First we need to find out HCF of X and Y. Okay, we will get something here. For example, if P is a HCF, so P and Z we need to find out HCF again. Okay, so HCF of P and Z. So this will be the answer for this question. Okay, so with the examples you can easily understand. So if you want to find out more than two numbers HCF, first we need to find out HCF for any two numbers. Then we need to combine with the other one. Okay, so hope I am clear with this as of now. That is the product of two numbers. The product of two numbers is the product of their HCF and LCM. Okay, now we have taken 16 and 18 previously, right? So I'll go with that numbers only because we already find out the HCF of 16 and 20. Okay, so we have taken 16 and 20 are the two numbers. Now what is the LCM of these two? LCM of 16 and 20. What's the LCM of 16 and 20? That is 80. HCF of 16 and 20. HCF of 16 and 20 is what? 4. Okay. Now let's take here the product of two numbers. So the two numbers are what? 16 and 20. The product of two numbers is equals to the product of their HCF. What is their HCF? 4. And what is their LCM? 80. So the point here said these two are equal. So 1620 is a 320. 480 is a 320. Okay. So this is the point. The product of any two numbers is the product of their LCM and HCF. This one formula you need to remember because this will be helpful a lot in the questions. Now the next point says if you want to find out the fraction for LCM for the fractions. Okay, if you want to find out HCF for the fractions, you just need to remember HCF of numerator by LCM of denominators, that is HCF of factors. And LCM of fractions is what? LCM of numerators by HCF of denominators. Then you may get confused. Simple. If you want to find out HCF of fractions, numerator will be HCF of numerators and the denominator is LCM of denominators. See, on the top it will always be numerator, on the bottom it's always be a denominator. So on the top it's always a numerator, on the bottom it's always a denominator. That is clear. Now you may get confused about HCF of numerators or LCM of numerators. Simple. If it is asking about HCF, the top word should be HCF and the remaining word should be LCM, that is in the below. And if you want to find out LCM of fractions, the top should be LCM. The top should be LCM. The remaining word should be the below. Okay. So HCF of fractions find out చేయాలంటే పైన HCF రాయాలి, మిగిలింది కింద LCM రాయాలి. And LCM of fractions find out చేయాలంటే పైన LCM రాయాలి. అంటే ఏది కనుక్కోవాలంటే అది పైన రాయాలి, మిగతాది కింద రాయాలి. ఓకే, సో యూ కెన్ రిమెంబర్ దిస్ మెథడ్. ఓకే, నౌ next. So these are all the questions. So simply numbers ichi, sometimes they need to find out LCM, sometimes applications are also given. Okay, so application of LCM and application of GCD is also given. Okay, now I'll explain this one. There are three numbers. The ratio of the numbers is given as 3 is to 4 is to 5. Okay, the ratio of numbers is given as 3 is to 4 is to 5. Okay, that is 3. We already discussed the ratios clearly. So if the ratio is given as 3 is to 4 is to 5, what we can consider as the numbers? Okay, so the given numbers. Okay, the given numbers we can understand like, which is 3x, 4x and 5x. Okay, so if a ratio is divided, it should be come with a x. Okay, so 3x, 4x and 5x, those are all the numbers, and their LCM is given as 2400. So LCM of 3x, 4x and 5x is given as 2400. Okay, now how do we find out LCM of 3, 4 and 5? Okay, 3, 4 and 5 LCM, how do we find out? See, there is no common multiple here, so obviously we need to multiply with 3 into 4 into 5. So 3 4s are 20, sorry, 3 4s are 12, 12 5 is 60. So 60 is a common multiple of this one. So what is the LCM of 3x, 4x and 5x? That is 60x. 60x is equals to 2400. Now from this x is equals to what? 400, sorry, 40. So x is equals to 40, then we can get it. So after getting x equals to 40, then the numbers are, okay, their HCF we need to find out. So for that, first we need to find out those numbers. So what are those numbers? Those numbers are what? 3 into 40, which is 120. Next 4 into 40, that is 160. And next 5 into 40, that is 200. So these are all the numbers. Now highest common factor. Okay, so other than 1 we don't have any other common factors. Now to find out the common factors of this, how do we find out the common factor? See, 40, 40, 40. It's multiplied by 40, no? Every time it is multiplied by 40, you can directly take it as 40. Because for 3, 4 and 5, we don't have any common multiple other than 1. But here, 3 into 40, 4 into 40 and 5 into 40. That's obviously a common multiple. Or else if you want to find out, you can do this method. 120, 160. Okay. So 121 is a 120. Next we'll get it as 40, 40 120s, which is 3 is 120. So here we are getting 0, which means HCF of 120 and 160 is what? 40. Now we need to find out HCF of 40 and 200. Okay, so HCF of 40 and 200 will be what? 200 40s. 45s are 200. See, 0, which means the 40 is the highest common factor of 120, 160 and 200. Okay, so the answer for the question is 40. So hope I am clear with this. Now number, the greatest number of 4 digits. Okay, so first we need to think about the greatest number of 4 digits. So what is the greatest number of 4 digits? That is 9999. Okay, so instead of checking each and every number is that divisible by 9999, we'll just check it because we need to find out the common. Okay, we need to check it. LCM of 15, 25, 40 and 75. Okay, so for this common multiple we need to find out. So 600, okay, 40 and 75. అన్ని 5 multiples లాగే ఉన్నాయి. So 5 3s are 5 5s are 5 8s are and 5 25s are, okay, sorry, 25s are 5 15s. Okay, this is 5 15s. Next malli we have 5 common here. So 3 1 8 3. So we have 3 here, 1 1 8 and 1. Okay, now you need to multiply. So 8 3s are 24, 24 25. Okay, 25 24s. That will be 25 into 24, which is 600. Okay. So the common multiple of these will be what? 600. Okay. Now this 9900 is divisible by the 600 or not? If it is divisible, 9900 is only the number which is divisible by all these numbers. Okay. So ఏదైనా నెంబర్ 600 తో divisible అయితే ఆ నెంబర్ ఖచ్చితంగా ఈ అన్నిటితోని divisible అవుతుంది because 600 is a common multiple కాబట్టి. Okay. Now, so I am just checking 9999 is divisible by 600 or not. Okay. Now 600 దేంట్లో పోతుంది 600 6 కాదు 600 600 into 12 12 6 is 72 600 into 16. Okay, so 600 into 16 16 6 is 96 kada 600 16 same అవుతుంది 9600 we left with 399. Okay, so what is this 399 remainder indicates? If we subtract 399 from this 9999, the number is divisible by 600. Okay, so our required number is what? 9999 minus 399, which is equals to 9600. Okay, so this 9600 is divisible by 600, which means this is divisible by what? 15, 25, 40 and 75. Okay, so this is how we need to solve the question. Okay, so I am just assuming those two numbers are okay. We need to find out the numbers. So those two numbers, let us assume the two numbers. So let us assume the two numbers are A and B. Okay, so here A is given as 360. We need to find out B. That's the question. We need to find out the other number. Okay, now here something is related to sum of LCM and HCF of those two numbers is 760. Now LCM of two numbers. Okay, LCM of A and B. So let us write like this: LCM of A and B is, let us take it as L. HCF of A and B, let us take it as H. I have already told you in my problems on ages class, that is, try to take the first letter of the noun as a variable instead of taking X and Y. Okay, so I have taken a good examples on that day as well, why we have taken L and H, or why we have taken first letters. Now here just convert this data into the equation, which is sum of LCM and HCF. So which is L plus H is equals to 760. This is the first equation which is given, and LCM is 18 times their HCF. So LCM is means equal 18 times of HCF. This is the second equation. Okay, now one number is given as 360. Now we have two equations here and two unknown variables, which is L and H. So we can easily find out. So I am substituting 2 in 1. So from that, what we can get it? 18H plus H is equals to 760. 19H is equals to 760 and H is equals to 40. Okay, so 19 fours, 10 fours are 40. Okay, 80. 19 eights are no 1940s. 19 4 studies. Yeah, 1940s. Okay, that is HCF. So after knowing HCF equals to 40, so L plus 40 equal to 760. Now from here L equal to what? 320. Now we know that LCM of two numbers is 320, HCF of two numbers is what? 40. So this is 320 and this is 40. Okay, now we know that LCM of two numbers, and we know that HCF of two numbers, and we know one number is 360. Now did you remember any formula here? Yes, we have a formula, that is what? LCM of two numbers is equals to, what is that? See, the product of two numbers is equals to the product of their HCF and LCM. So here we have four terms, that is what, two numbers product and two numbers LCM and HCF. So we use this formula to find out. Okay, so what's the formula? That is the product of two numbers. Okay, so the product of two numbers. So the product of two numbers is equals to the product of their LCM and HCF. So A is here as given 360 plus B we need to find out. LCM is 320 into HCF is 40. Okay. So 361 the 3 sorry 720. 361 the 362 are. So B equal to what? 40. So answer for the question is 40. This is how we need to solve the question. So answer for the question is 40. That's there here. No, 80. Sorry, that is 80. The answer for the question is 80. Okay. So I'm just finding the common multiple of all these. Okay. 1 1. Okay, 1 1 1 kada. Okay, done. Next, nothing common here. So 2 5s are 10, 10 3s are 30, 32s are 60, 62s are 120. Okay, so which means what? For 120 minutes, okay, for every 120 minutes, the bells will ring uniformly. The bells will ring at a time. So 120 minutes means what? Sorry, 120 seconds. Sorry. This is 120 seconds. So for 120 seconds, the bell, all bells will ring at a time. So 120 seconds is nothing but what? 2 minutes. Okay. So 2 minutes the bells will ring simultaneously. Now in 30 minutes. So in 30 minutes, how many times it will ring? So which is 30 by 2. 30 by 2 ante 15. Okay. 15. Kani, if you observe this, 15 and last, okay, first 2 minutes, then first 2 minutes ki, then 4 minutes ki, then 6 minutes ki. Okay. So 15 plus 1. Total 16 times they'll ring at a time. Okay. 16 times. So first we need to find out the difference between all these. Okay, so what's the difference between 13 and 7? 6. 13 and 27 ki, which is 14. 27 and 7 ki, which is 20. Okay, so we need to find out GCD of these three. So if you find out GCD of these three, then that is the greatest number, okay, which will leave the same remainder in each case. So if you go with the traditional method, I won't suggest you for this question. Just remember this, remember the question, remember the solution like this. Okay, so we need to find out the difference of those two, and if you want that, you need to go with some smaller numbers. So simple numbers observe chesi and you can find it. Otherwise you can blindly remember this method. So 13 minus 7 6, 13 minus 27 is 14, 27 minus 20 is 40. So GCD of this, GCD ela find out chalo, you know it. Okay, so 2 is the number, the greatest number which will divide this. Now if you want, you can check it. So 7, if you divide by 2, 2 3 is a 6. Okay, the same remainder we are getting. 13, if you observe, these all are odd numbers. Okay, if these are all odd numbers, it leaves you the same remainder. See, 27, 2, and which is what? 13, 26. See, 1. So for every time you are getting the same remainder in each and every case, and these three are all what? Odd numbers. So answer for the question is 2 in this case. Okay.